Assalamu alaikum viewers, please like, share and subscribe this channel. Links of PDF files used in this video are given in description. So today is a part 7 of a lecture series about atmosphere and pollution, and in this lecture we will mainly focus on modern or photochemical smoke. Previous lecture we have discussed classical or industrial London smoke, but in this lecture our focus will be on modern photochemical smoke. So as we have seen in the previous lecture that the word smog is actually the combination of two words, which is fog and smoke. So the smoke which is produced due to the air pollution and the natural phenomena of fog, both these combine together to form smoke. Actually there are two types of smoke. Number one type is called as industrial. It is also called as classical, reducing, London or black smoke, whereas the other type is called as photochemical, modern, oxidizing, Los Angeles or yellowish in color smoke. So these are basically two types of the smokes. The reason of this smoke was because of the emissions from industries. This is called as classical smoke, as it was in the previous time. Similarly, it was reducing in nature because of the contents that were found in that smoke were carbon and the oxides of carbon and sulfur dioxide, etc. So that is why this smoke was reducing in nature. The major incident of this type of smoke was happened in London, so that is why it is also known as London smoke. It was blackish in color, and the main culprit behind this smoke was the coal, which was the main industrial fuel at that time. Nowadays the smoke appears, it is called as photochemical smoke because of the nature of the chemical reactions that are taking place in this type of smoke. This is also called as modern smoke because nowadays this type of smoke occurs. It is oxidizing in nature because the contents present in this smoke, they are oxidizing in nature. And then the biggest the incident of this smoke was happened in Los Angeles, USA. So it is also known as Los Angeles smoke. It is actually a yellowish brown haze in color, so that is why the photochemical smoke is yellowish in color, and it is the characteristic of photochemical smoke. In the previous lecture we have discussed in detail the London smoke or the reducing smoke, how that smoke was formed, what was the chemistry behind that smoke, and what were its effects. Now in this lecture we will mainly focus on photochemical smoke, and the smoke content of this photochemical smoke is mainly consisting of following substances. These include sulfur dioxide, nitrogen oxide, ozone and particulate matter. Remember that here this ozone is not the stratospheric ozone, but this ozone is created in the lower atmosphere. This ozone is also called as ground-level ozone or tropospheric ozone. Photochemical smog is an urban phenomenon. It means this is occurring in large cities, and it is not some phenomena that is occurring in some rural areas. So it is urban phenomena, and the urban population is characteristic of two things. Number one is industries and number two vehicles. So due to industry and number of motor vehicles, it is more of a problem in large cities, and the characteristic of environment in large cities due to the industries and motor vehicles is the environmental conditions are warm, they are sunny, and the climate is usually the dry. So in this way, the yellowish brown haze appeared in large cities, and that is why this is the biggest characteristic of photochemical smoke. The initial signs of photochemical smoke started appearing in 1940s. During World War II, there was massive wartime immigration to Los Angeles. Los Angeles was the largest car market in the US. There was tremendous industrial activity and huge influx of cars. More than a million cars piled in the city at that time. Similarly, diesel buses had just made their appearance in 1940. The automobiles and the industries spewed the smoke relentlessly. The city started witnessing these small bouts of fog. However, the first disastrous attack of big smoke was on July 26, 1943. First time when the incident of smoke appeared, then the residents of the LA that were fond of the vehicles, they were of suspicion that it was some warfare attack by Japanese. However, later on, it was concluded by various chemical scientists that actually the exhaust from the automobiles and hydrocarbons in the presence of sunlight reacted to form the products that cause photochemical smog. So it was very difficult for the people to accept this reality that vehicles are the main culprit behind the photochemical smog. There was a Southern Californian gas company's plant in the LA, and that was manufacturing actually butadiene, an ingredient in synthetic rubber, and it was held responsible for the thick cloud of the smoke. But and the factory was also shut down temporarily. But later on, it was found that not this plant was behind the smoke, but it was the cars or vehicles, including buses. So, what are the conditions under which the photochemical smog is formed? So, actually, there should be a dry environment or atmosphere. The air mass should be stagnant. There should be no wind movement or a massive scale. There should be a condition of temperature inversion, and there should be presence of intense sunlight which is containing the wavelength of 400 nanometer, and that comes in the UV region. So, photochemical smoke occurs in these conditions, and the driving force behind smoke formation is actually the electromagnetic radiation from the sunlight. And this UV region, just shorter than the lower limit of visible light, is readily available from the radiations that are coming from the sun. So, energy absorbed by the molecule from this radiation can result in the formation of active species, thus initiating the photochemical chain reactions. So smoke is produced in a series of chain reactions. There are two different series of chemical reactions which can take place in the formation of photochemical smoke. The first involves only nitrogen oxides formed by the combustion reactions. So in the first step, people begin driving in the morning, and nitrogen reacts with oxygen in the extreme temperatures of the combustion engine. So first reaction is that nitrogen which is coming from the fuel of the vehicles is combining with oxygen to form nitrogen oxide. In the second step, after few hours, the NO which is formed in the first reaction then combine further with the oxygen and produce nitrogen dioxide or NO2. In the third step, the nitrogen dioxide absorbs sun radiation energy or light energy, reforming nitric oxide or NO and generating a highly reactive oxygen atom. The NO then can go back and it can again initiate the second step or the second chain reaction, or it may be used further in the chain of this reaction. So NO2 absorbs light to produce NO and oxygen. So this is the third step. In the fourth step, in the presence of sunlight, the oxygen atom, or which is having a free radical, combined with oxygen molecule to form ozone. So this is called as ground level ozone or tropospheric ozone. So this is the first product of photochemical smoke. The ozone formed here in the step is then consumed by the already present NO. So both these species react together to form nitrogen dioxide and oxygen. So these reactions result in the accumulation of various oxides of nitrogen in the atmosphere. So that is why the yellowish haze or yellowish brown color is due to these oxides of nitrogen. So some ozone which have the health and environmental effects is remained in the reaction, but it is consumed partially in the next reaction. So what it means that ozone produced here is not totally consumed in the next reaction. Only a partial amount of this O3 combined with NO to form NO2 and O2, whereas other ozone remain as it is in the atmosphere, and that ozone is called as tropospheric ozone or ground level ozone, and which is very toxic not only from health point of view but also in deterioration of material things such as plastic and rubber. So apart from producing ozone, the NO and NO2 can also enter into a second cycle of chemical reactions by reacting with volatile organic compounds or VOCs. So the R here represents the volatile organic compounds. So as a result of this reaction, oxygenated organic and inorganic compounds are produced instead of ozone, and this type of oxygenated products produce further various types of volatile compounds. So the nitrogen oxides then further reacts with these volatile compounds to form NO2 and other products, and this NO2 again enters into the new cycle to form the various products. So because the nitrogen oxides react with volatile organic compounds in this second series of reaction, ozone is no longer break down in the first cycle. Instead, ozone is allowed to build up. The accumulation of ozone and volatile organic compounds along with the energy from the sun forms the brown photochemical smoke seen on hot sunny days. So this diagram explains the cycle of photochemical smoke or how it is produced. So actually there are two types of pollutants that are present in the photochemical smoke. First, there is the presence of nitrogen oxide and nitrogen dioxides, and these nitrogen oxides and nitrogen dioxides are emitted from the industries and vehicles. Plus there are volatile organic compounds, and these are also emitted from various anthropogenic sources. Both these react together to form the secondary products, and the one of these secondary product is ozone, whereas the other toxic secondary product is pan, which is also called as peroxyacetyl nitrate. So photochemical smoke is mainly contains these secondary pollutants at the end. So the primary pollutants are those which are produced directly from the emission sources, whereas secondary pollutants are those species that are produced after reaction of primary pollutants, and with the passage of time, if further entry of primary pollutants stops in the atmosphere, then gradually the concentration of secondary pollutants increases, because the primary pollutants after doing various chemical reaction has been converted into the secondary pollutants. So if we summarize that, there are three major products of photochemical smoke. The first major product is called as peroxyacetyl nitrate or PAN, and this is the structure of man. Second is the ground level ozone. This is also called as tropospheric ozone, and this is the structure of this ozone. And the third product is called as formaldehyde. So the presence of formaldehyde and other volatile compounds means the production of more than 100 oxidizing products that will be present in the atmosphere. There are various harmful effects of photochemical smoke. Smoke adversely affects human health and comfort as well as plants, materials, and atmospheric quality. Ozone is the smoke constituent that is generally regarded as being most harmful to humans, plants, materials. Although other oxidants and some of the noxious organic materials such as aldehydes are also harmful, their effects may be especially pronounced for individuals undergoing vigorous exercise because of the large amount of air that they inhale. On smoky days, air pollution alerts may advise against exercise and outdoor activities. Plants are also harmed by exposure to nitrogen oxides, ozone, and peroxyacetyl nitrate, as all these species present in the smoky atmosphere. Pan is the most harmful of these constituents, damaging younger plants' leaves especially. Some plant species are extremely susceptible to damage by chemicals in smoke and are used as bioindicators of the presence of smoke. cost of crops also decreases if they are damaged by the smoke. Materials that are adversely affected by smoke are generally those of attacked by the oxidants. The best example of such material is rubber, especially a natural and synthetic rubber, and this is mostly attacked by the ozone. Indeed, the hardening and cracking of natural rubber has also been used as a test for atmospheric ozone. Visibility reducing atmospheric aerosols particles are the most common manifestation of the harm done in the atmospheric quality by the smoke. The smoke formation process occurs by the oxidation of organic materials in the atmosphere, and carbon containing organic materials are the most common constituents of the aerosol particles in the atmosphere. So if we summarize that these are the major points, that the contents of the smoke are potent oxidizer. They are very highly irritating to eyes, they are irritating to mucous membranes of the respiratory tract. Similarly, they damage the vegetation, they damage the material, they reduce visibility, and they produce aerosol particles. And these aerosol particles have their own harmful effects, ranging from visibility to various serious human ailments such as cardiovascular and respiratory diseases. So, if we summarize that, photochemical smog is a mixture of pollutants that are formed in the presence of NOx, volatile organic carbon, and sunlight. The harmful effects of the smog on human health, and especially the senior citizens and children, and also people with heart and lung conditions, are mostly affected from this smoke. On the other hand, the industrial smoke is a mixture of soot, particulate matter, and sulfur dioxide. The sulfur dioxide in industrial smoke can also lead to sulfuric acid, and that sulfuric acid can cause acid rain. Along with that, sulfuric acid enhance the droplet size of the fog, as a result of which the surface area of the drops increases, and on this surface the conversion of primary pollutants into secondary pollutants enhances, and that further aggravate the effects of the smoke. So this was all about today's lecture. I hope you have well understood this lecture. But still, if you have confusion in your mind, or if still you have questions, then you can ask those questions in the comment section. I will respond to your queries as soon as possible. Okay, thank you. Allah Hafiz.